Okay, now that you've seen a few examples and have a little bit of history on these machines, let me explain what each component is and what it does, to some degree anyway, because I really don't understand them completely. I just know what I need to know to make them work, and that's about it. Okay, the machine consists of counter-rotating discs, or plexiglass discs, with foil sectors pasted to them. It's an even number of sectors, and these bars right here are neutralizer bars. And I don't really understand completely what they do, but they contact they got little soft brushes that rub on the sectors and neutralize the charge across the disc. Okay. Right here, we've got collectors, and I've designed these collectors where they retract so you can remove the discs without damaging them, because the collectors have little points on them, and anything pointed on these machines will either discharge or pick up a charge. So on the charge pickups, it's advantageous to have them pointed, but the rest of the machine needs to be very round to avoid losses. Anyway, these are the collectors. And connected to the collectors are electrodes. And that's where you see the result of the charge. It's through the discharge on these balls. But the collectors are also connected to capacitors. That's these two items right here. And they're very simple. That's a capacitor. And it's a bar called electrode, if you want, stuck down in some BBs, and the BBs are on the inside of this. This is a drinking glass, is what it is. The BBs are on the inside, and this foil's on the outside. And if you're familiar with electronics at all, that's a capacitor. That's all that is. Some people call them a Leyden jar, because that's what they were called when they were used on these machines. But this outer foil, I don't know if you can see that or not, it's wrapped around the bottom. There's a metal disc in that little cup right there. And underneath that cup, let me tip the machine up. There is a bar. It's a copper bar. And it doesn't need to be a big copper bar, it can just be a fine piece of wire. It's just convenient to bolt that bar on there. But that's a conductor between the two outer, that connects this foil and the foil on the other capacitor together and completes the circuit. That's the capacitors and how they go into the circuit. Then the drive mechanism. This drive mechanism on this Wimshurst is fairly unique, and it's not a real common drive, although other people have made this system. The original Wimshurst reversed this back belt by twisting this belt. They put a twist in it and put it over this top pulley. And what that did is it reversed the back disc, but it also made that brush or that belt rub against each other, and it would wear out that back belt. So I opted for this drive, and it's a little bit confusing. It's got two lower pulleys that allow this back pulley to turn in the opposite direction. This one here is connected to this crank, but it's on a bushing. It's a bearing. It's totally independent. In fact, it'll slide on that shaft. This one here is connected to the crank. It's stationary and doesn't move. So the front one is the drive pulley, and the other one acts as an idler. And you can see this is quite efficient. You don't have to hardly turn this to get a spark. So anyway, the first step to building this thing is the wood platform. Let me discuss one more thing first before we head into the construction. Always want to do that. Anytime you're going to point at the machine, you want these two balls touching together. Those capacitors hold a charge. See there, I got those capacitors are charged now. Even though the machine has stopped, I had a charge in there. Touching those electrodes together makes the machine safe to touch. This post right here is a support for this electrode assembly. It's insulated. That's a piece of PVC pipe. It's got a metal connector on the bottom and the top, but in between is insulated. That's super important. There's various different ways to make these machines. I could have put the electrodes up on top, could have put them on straight at an angle on the front. In fact, this machine we're going to make is going to be this basic machine with a different style of electrodes. And I'm going to try to keep it simple too. And they're kind of expensive. These things got brass all over them. But the only reason for brass is one, looks, and two, it's easy to solder and easy to work with. But the negative on that is two negatives. Brass is expensive and it doesn't stay shiny. You can shine this machine up and buff it, and by the time you get done putting it all together, it's already started to tarnish. Ideally, nickel plated would probably be the best. But steel's okay too, but steel rusts. But however you want to build it, I use brass because it looks nice and it's convenient. But certainly any kind of metal works, even aluminum. But like you can't solder aluminum, welding it's pretty difficult. So anyway, let's get started, and we're going to start with the base. Okay, I've got the parts cut out for the base here. This is 2x24, 2x24, 6x6, 6x6. But I made this dimension slightly over. This is 6 1/8, 6 1/8, and this is 2 1/8 inches wide. And the reason I did that, after I assemble this, I'm going to dowel it together. I can trim the edges and trim the sides and everything will be flush. If I get a slight misalignment, it won't matter. But before I dowel it together, I need to cut 2 notches, one right here and one right here, that will secure our uprights to hold the discs. So that has to be exactly center. So 24 1/4 long is 12 1/8. And I like to measure that from both ends. 12 1/8. Okay, now because I want them the same length from, if I get any kind of, I'm going to cut them together, and if there's any kind of off-center discrepancy, I want to keep the orientation the same on each end. So I'm going to put an X right here and an X right here. So I'll do like this. And I'll cut that in the table, cut that notch out in the table saw, just like that. And the notch needs to be, I don't remember, 1/2 inch deep and 2 inches wide. 1/2 inch deep and 2 inches wide. So, it can be slightly over 2. Most critical thing is that it's centered, and then it needs to be 1/2 inch deep. And no matter what, these got to be flush on the ends, because I'm cutting them both at the same time. I want them to be exact. cut both ends because that's the critical one. Now I'm just wasting the center part out. Okay, I've got my X's on the left side here like I did before. Okay. See, I've got a very slight discrepancy right here. It's square against here. Something's not exactly square, but that's why I made it oversized. Okay, right now that's where we want it, and what we want to do is draw where we want our dowels. And it doesn't really matter, as long as they're not real close to the edge. Now you could use biscuits for this, you can use dowels, you could use screws, although I don't really like the idea of screws because we're going to be drilling some holes, and depending on where we drill these holes to mount the capacitors or whatever, those screws might be in the way. But you could use screws, you just got to take into account where the holes are going to go. Dowels, you can drill right through them, same with biscuits. You could just don't put anything in there. It would probably work just fine. Just rely on glue. Now, to make sure this is assembled the same way, I'm going to put an A, B, B, C, C. That's got to be D. Okay, we're at my boring machine here. Line the marks up and drill. I got a video on this boring machine. It works great. It would be better if it had a 3450 motor on it, however. This one's got a 1750. It works, but 3450 would be better. Okay, we're ready to dowel. However, I found out from experience it's a whole lot easier to sand this inner surface right here. It's hard to sand in between two pieces like that. Better to sand it before you assemble it on the edge. Okay, we're ready to assemble. There we go. That's another advantage to making this oversize. The marks I put on there with the clamp will be trimmed off. So here's a trick I learned a while back. a random orbit sander hooked up to a vacuum cleaner. Makes a huge difference on the effectiveness of that sander. Makes it sand twice as fast. It removes the sawdust, so you're not sanding sawdust, you're sanding wood. Highly recommended. Well, before I finish sanding this, I think I'll cut it down to size. You may remember I made it 24 and a quarter long, so I can cut an 1/8 inch off each side, and I did the same thing this way. So I'm going to cut it down and then finish sanding the edges. Okay, I'm getting ready to make some pulleys here for this polycord belt. That's the drive system on the Wimshurst machine. This is a drive pulley and a couple of idlers, 5 1/4 inch. I don't remember what these are, but it's in the plans. I'm going to do it on my CNC. You can do it on a standard wood lathe very easily, just by mounting a bolt in a chuck. It works perfectly well. Now let's get started. Okay, if you have a standard wood lathe, get you one of these chucks. I think I paid $69 for that. This is an extremely handy chuck. Just put a bolt in there like this. The head is behind the jaws. Then you can do the same thing I just did. Manually, just like that. Okay, next thing we got to do is make some uprights. I've got a couple of 4 by 14 pieces here that I'm going to cut these out of. This is a 1/4 inch steel template. You could make this same template out of wood, 1/8 inch plywood, 1/4 inch plywood. That will be screwed to this wood, and it'll be used for a router bit to follow with a bearing on the router bit. You don't have to get this complex. You could make a 3 inch wide, put a curve on the top. It would look great. But I thought this is kind of classy looking. So, and I got the template now. But it's kind of a pain to make. And first thing you got to do is locate the holes, or cut the tenon, then locate the holes Well, let's just get on with it and I'll show you. The first thing I'm going to do is cut the tenons to fit in there. It's pretty hard to cut the tenons once you've cut that taper on it. Okay, that's the right depth that way. Now I've got to cut that off and that off. So I got a tenon that fits in there. So this is 4 inches wide, and that's 2 inches. So we basically need an inch off of each side. So I need to set my blade height at 1 inch. The width of that is 1 inch. I want it to be a little bit of a loose fit. That way I got some adjustment on it. So I need to cut it just like this. Yeah, need to go a little deeper. Here we go. Perfect. Got a little bit of extra for adjustment and a little extra on the bottom. I'll have a plate on the bottom that screws to that and it'll pinch in there. Okay, we've got to find the exact center of this. This is about 4 inches. So I'm going to put this at 2 inches. Center of that line, which hits pretty good, is exact center. Then look through those holes, center that line, and use a 3/16 transfer punch. Line up the bottom of the template, the bottom of the tenon there. Transfer that hole center. Okay, this is probably getting a little fanatical, but I measured the exact distance to center. Subtracted 3/16, which is half of 3/8. So I'm going to cut a 3/8 slot in that, and it's going to be exactly center. So this is going to be the distance between the fence and the rotor bit. Okay, I put a center mark on the end of that, so I should be able to touch that and see if I'm centered. So I'm just touching the outer edge of that router bit right now. So this distance here needs to be 3/16 greater. That's 3/8. Half of 3/8 is 3/16. So it needs to go 3/16 more than that. Perfect, perfect, perfect. Now, I'm going to screw the template to the wood, rough it out with my bandsaw, and then trim it with a router bit. This is the router bit I'm installing. It's got a guide bearing on the bottom and on the top. And that'll work to our advantage. Let me show you how it works. Okay, this has the potential to be dangerous. You really got to pay attention and plan ahead. I'm going to run into that router bit like that and trim like that. This router bit is turning this way. I don't want to end up like that. I want to end up like that. Otherwise it'll kick it. When I get up to this right here, I don't want to go down here because it'll break that corner off. As soon as I get to that, it'll break it off. So I'm going to do one side, turn it over, lower or raise the bit up so it's guiding from the bottom and go in this direction. It'll be apparent when I do it. I turn on my dust collection. Guide from that bottom bearing. I've got a little bit of sliver there that'll sand off. I didn't want to run into the metal with the cutting edge. That looks pretty good. Got a better idea. I got a drum sander on my Camelback drill press. Well, I think that wraps up part one. Next week we'll put some of the drive components on, the legs, the uprights, and maybe the support columns for the collectors and electrodes. And then we'll get into putting the disc on and making some sparks. Hopefully I can get this done in 3 parts. Anyway, thanks for joining me, and be sure and subscribe and ring that bell. That way you'll get notified when part 2 and 3 come up. Thanks for joining me.